Okay, these notes are double replacement reactions. In order for a double replacement reaction to occur, one of the products must precipitate out of solution. Otherwise, you just have four ions just kind of floating around doing nothing. The precipitate will either be a solid, liquid, or a gas. In order to tell whether a double replacement reaction will occur, we use solubility rules or a solubility table to check the states of the predicted products. You guys have a solubility table. It's on the back of the activity series that you used in class with the single replacement reactions. So that's what we're going to be using to do the rest of the problems in this video. Okay, in a double replacement reaction, the two positive ions change place. For example, if we start with sodium chloride and potassium nitrate, the resulting product should be sodium combining with the nitrate ion and potassium combining with the chloride ion, making the products sodium nitrate and potassium chloride. Now we just have to check to see if one of the products is not aqueous, but solid, liquid, or gas. So when we check our solubility table, we find that both products are aqueous. This means the reaction did not happen. Now, what I didn't type in here, and I should have, is we would actually write it as NaCl aqueous plus KNO3 aqueous. Now, you never have to check the reactants because I'm not going to give you reactants that aren't aqueous. You can't react anything for a double replacement reaction if it's not already aqueous. So if you have a solid product or something solid that does not dissolve in water, you can't react it in a double replacement reaction. You have to do something else, either burn it or do whatever, but you can't do a double replacement reaction. The reactants have to be aqueous. Okay, so now our product, when we check the solubility table, we find out NaNO3. So you look under sodium and then nitrate, and you see this little AQ next to it. And same with if you go under potassium and chloride, you see a little AQ next to it. Okay, so this means since both products are aqueous, it didn't happen. They're just, all four ions are just kind of floating around in the water going, hey, how you doing? We're not going to do anything. So no reaction. So then you just put NR at the end of it. Okay, let's try a few more. Predict the products of the following double replacement reactions. Include states for reactants and products in the chemical equation. And of course, we're also going to have to balance. Whoops. Ew, my pen didn't work. Balance it. Okay. Remember, I'm never going to balance an equation for you. You guys have to balance them. Okay. If both products are aqueous, then the reaction does not happen, so write an NR after the equation. You do not have to balance if it's no reaction. So I'm going to put NR equals no balance. I'm not going to make you balance the equation if it doesn't happen because it's no reaction. Okay, so let's get to it. Okay, so the first example is a solution of aluminum chloride is added to a solution of silver nitrate. Okay, so we're going to write aluminum chloride, which is AlCl3, and it's aqueous, because remember, we don't even have to look up the reactants. They're automatically aqueous. Because if I said a solution of, that means aqueous. And then silver nitrate, so AgNO3. So you guys will want your periodic tables and your polyatomic ion sheets out. Okay, so let's see what happens. Right now, we know that aluminum and silver are the ones that are going to change places. Okay, so our products are going to be aluminum nitrate, or at least we hope they're going to be aluminum nitrate. And I'm going to leave room for the states, and silver chloride, Cl. Now, the thing is, I'm not going to worry about balancing yet until I find out if one of these two is a product. Okay, if one of these two does not balance or not precipitate out, if they're both aqueous, then we don't have to balance it. Okay, so we look up on our chart aluminum and nitrate, and we find that this one is aqueous. Okay, not going so well, is it? Okay, now silver and chlorine, or silver chloride. Ah, that's a solid. So that's our precipitate. Okay, let's precipitate. So now I can balance it. So I got to put a 3 here and a 3 here. And that should be balanced. 3 silver, 3 silver, 3 nitrate, 3 nitrate, 3 chlorine, 3 chlorine, 1 aluminum, 1 aluminum. Okay, so the reaction is AlCl3 plus 3 AgNO3 yields aluminum nitrate plus 3 AgCl. Okay, so that's how that goes. Let's try the next one. Okay, in this example, it's a solution of sodium hydroxide is added to a solution of hydrochloric acid. Okay, so we got sodium hydroxide is NaOH. It's added to a solution of hydrochloric acid. Now, this one's a little trickier. Your sodium and your hydrogen switch places. So you're going to get sodium chloride, and I'm going to leave room for states, but then you get HOH. Well, HOH is H2O. And when you get H2O, it's automatically liquid. I don't know if I even have it on the solubility table. I think I do, if you look under hydrogen hydroxide, because that's kind of how you would name water in this case, since it's a double replacement with the ion switching. But whenever you get HOH or water, it's automatically liquid, so it's automatically a precipitate. You don't even have to look it up. As far as the NaCl, if you look under the solubility table, you do find that's aqueous. So now let's balance it. Oh, guess what? It's balanced. I made it easy for you. Okay, so your water will always be a precipitate. Okay, always. Okay, example 3. A solution of magnesium bromide is added to a solution of aluminum sulfate. So let's write our, let's see, we got MgBr2 aqueous plus aluminum, and I'm going to leave spaces in here to balance it, aluminum sulfate, Al2 SO4 3 aqueous. Okay, now our product should be the magnesium and the aluminum are going to be changing spots. So magnesium sulfate plus aluminum bromide. Okay, so now let's go ahead, before we try to balance it, let's look on our solubility table. Ooh, we get magnesium sulfate is aqueous. Okay, let's hope aluminum bromide is solid. Nope, aluminum bromide is also aqueous. So in this case, now you can either cross it out like I like to do and put NR, or just put NR next to it. I like kind of crossing it out, so that shows me, hey, it doesn't work. So we don't have to balance it because your answer is no reaction. Okay, the last one, at least on this video. A solution of lead 2 nitrate is added to a solution of sodium hydroxide. Okay, so lead 2 nitrate, PbNO3 2 aqueous plus sodium hydroxide aqueous. Now, the lead and the sodium change spots. Remember, the lead is lead 2, so it's got to have a +2 charge. So we'll put the lead first. So it's going to be lead 2 hydroxide and sodium nitrate. Now, if you remember from the previous slide, well, the very first slide or second slide when I was talking about the first example, we know that sodium nitrate is aqueous. So it's a matter of looking up the lead hydroxide. Okay, now this is lead 2, and there's also such thing as lead 4. But on the solubility table, it just says lead. And that's because lead 2, lead 4, no matter what oxidation state, no matter what charge the lead has on it, it acts the same when combined with the anions at the top. So lead 2 hydroxide and lead 4 hydroxide are both insoluble in water. So they both form a solid precipitate. The only two that differ is the mercury, which is why it has mercury 1 and mercury 2 on the solubility table. Most of the other transition elements, no matter what charge it has, it acts the same. So we don't have to worry about it. Okay, So we do have a product here. So now we have to balance it though. Okay, so we've got 2 nitrates, so we have to put a 2 there. 2 sodiums and 2 hydroxide. There we go. Okay, hopefully you don't have any questions. Hopefully you can use that solubility table. We will do a warm-up and tomorrow, and hopefully that'll help. So I guess that's it for these notes. Bye.